Good day, fellow. What I'm going to do, I'm going to explain the state of matter even further. State of matter. Do you still remember last time we said the term matter implies anything that has mass and occupies space? Then the building blocks of matter, atoms. Okay, now let us take a solid phase together, the liquid phase and a gas phase. Now we have three phases: a solid, a liquid, together with a gas. We just want to know, when we move from solid to liquid, we call that state what? Melting. From liquid to gas, boiling or evaporation. Then now from solid straight to gas, we call it what? Sublimation. You see? Then now let us work in opposite direction. Now from gas to liquid, we call it a condensation. From liquid to solid, we call it freezing. Then now from gas straight to solid, we call it a deposition. See, we have three phases of matter: solid, liquid, gas. Let us now compare these three phases using what? Space. As for solid, we know that there are very small spaces in between. You see, there are very small spaces in between. As for liquid, the spaces of a liquid, they are more than of what? Of a solid now, but less than of what? Of gas. The reason that we said the solid phase has small spaces is because its particles, they are closely packed to each other. See now, let us consider liquid. Its spaces are let me write like this: spaces are less than of gas, but more than of what? Of solid. Now you see, then now of gas, they are very far apart from one another. See, they are very far from one another. Now let us consider kinetic energy. Kinetic energy for solid. Solid has a very small kinetic energy. Let me write AK. Small kinetic energy, because the particles, they are fixed more in like one position. Then as for liquid, the kinetic energy of, let me write, kinetic energy of liquid, it's more than of solid, but less than of gas. Then of gas has more kinetic energy of, or let me write, gas has more kinetic energy. You see, has more kinetic energy. See, now let us consider what the potential energy. The potential energy of what? Of solid now. As for solid, they are strong force of attraction between those particles. Strong force of attraction. Strong force of attraction. As for liquid, its particles, they are stronger than of gas, stronger than of gas, but weak. Stronger than of gas, but weak than of solid. Then the force of attraction between the particles of gas, they are weak. Oh, let me write the force of attraction. They are weak. You see, they are weak. Now let me consider these two curves. I want you to look at these two curves. Okay, I won't take long. I'll be done just now. See, let us consider now these two curves. We have the first curve here and the second curve here. Then we have time this side. We have temperature. Let me write temperature this side. See, going to write a heating curve. Heating curve this side. Also have a cooling curve this side. Okay. See, I hope you can see. Suppose here is 0 degrees Celsius, somewhere here it's 100. Then let me draw of a cooling curve. See, let's say somewhere here is 100 degrees and somewhere here is 0 degrees. We have, let's say I have A, B, C, D, E. Say I have E, I have D, C. We have now B somewhere here, and here we have A. What I'm going to do now is I'm going to explain each using each letters, focusing on a heating curve first. In a heating curve, we move from solid phase to gas phase. Then as for cooling curve, it's an opposite. We move from gas to liquid, or liquid to solid. Somehow we move backwards. Then as for heating curve, we move like forward from solid to gas. Then at A, what is happening at A? At A, we get a solid phase forward now of an ice. See, below 0 degrees Celsius. Then at B, this state from this point up until this point, the melting point, melting point. That's when now our ice changes its phase from solid to liquid. You see? Then at C, in fact, at this point, as we continue like this, we get what now? Our liquid. At D, it's a boiling now, the boiling point. You see? That's where now we see what? A liquid changing into what now? Into gas, up until this point. From there, we get what? A gas. Now I'm still looking at this diagram, a heating curve. Let me draw dotted lines like this, some dotted lines like this. See, some dotted lines like this. Then this is the scenario for what? For heating curve. Then let us move to this one now. I'm going to do the same A, B, C, D, E. Looking at this now, curve. From this one, we move opposite to this one. Somehow it's like we are going to start with E and go up like this. You see? To this one. At E, we get what now? We get at E, sorry, at A. Oh, let me start with E. Allow me to start with E, then D, C, B, A. At E, we get what? Gas phase. A gas phase up until this point. What is going to happen from this point up until from this point up until this point now is we are going to get a situation now whereby a gas changes into what? Changes into liquid. You see? Changes into liquid. This side we said it's boiling, but now this side we are going to say it's condense or condensation. Condense. At C we get what? Liquid. At C we get a liquid now. It condenses until it forms what? A liquid. You see, from gas to liquid. At C we get liquid. Now we want to know what is going to happen from this point up until this point. We are going to get a situation now we move from liquids to solid. That state is what now? Freezing. Then until it reaches what? A solid phase, which is what now? A, and ice. I thank you. I wanted to clarify the concept of heating curve as well as cooling curve. Now you can see the difference between the two graphs. It's like for this one we move up, this one we move downwards like this, but you have to keep these two, let me say 1 2 3 4 weights in mind. You see? Thank you.